Higher Secondary Examination 2023. Mathematics. Full marks 100. Pass marks 33. Time 3 hours. Attempt all questions. The figures in the right margin indicate full marks for the questions. For question numbers 1 to 4, write a letter associated with the correct answer. Question number 1. The principal value of cos inverse of minus 1 by root 2 is pi by 4, minus pi by 4, 3 pi by 4, 5 pi by 4. The principal value of cos inverse of minus 1 by root 2 is one of them. The answer is 3 pi by 4, that is C. Cos inverse of minus 1 by root 2 is equal to pi minus cos inverse of 1 by root 2. But cos inverse of 1 by root 2 is equal to pi by 4. Pi minus pi by 4 is 3 pi by 4. Question number 2. The integral of cosec x dx is log of cosec x minus cot x plus c. Answer is D. For question number 3, a homogeneous differential equation of the form dy by dx equal to g of y by x can be solved by making the substitution a. Y equal to vx, v equal to xy, x equal to vy, y equal to v. For this, the y is dependent variable and x is independent variable. Therefore, the standard substitution is a. That is y equal to vx. Answer is A. For question number 4, if a vector, b vector, c vector are unit vectors such that a vector plus b vector plus c vector is zero vector, find the value of a dot b plus b dot c plus c dot a. Options are 3 by 2 minus 3 by 2 plus half minus 1 by 3. Correct answer is B. Its solution is modulus of A, modulus of B, modulus of C equal to 1, and their sum is also 0 vector, and whose modulus must be 0. Squaring on both sides we have this, whose square is equal to A plus B plus C dot A plus B plus C equal to 0. Expanding we have this, but A dot A is equal to modulus of A square, B dot B is also modulus of B square, C dot C is also modulus of C square. Others are A dot B and A dot B. We have twice of A dot B plus B dot C plus C dot A equal to 0. But magnitude of A is 1. Substituting their respective value and solve, we have A dot B plus B dot C plus C dot A is equal to minus 3 by 2. Question number 5. Define an equivalence relation. A relation R in a set X is an equivalence relation if R is reflexive, symmetric, and transitive. Ahumok chumlabadi relation R as equivalence relation kaugari. Question number 6. What is the range of the principal value branch of the function tan inverse X? Tan inverse X ki range kaya no? Magi principal value branch taliba magi range tu kaya no? The range of tan inverse X is open interval minus pi by 2, pi by 2. Question number 7. Find the value of sine inverse of 1 by 5 plus cos inverse of 1 by 5, which is equal to pi by 2. Sine of pi by 2 is 1. Question number I. If a matrix has 15 elements, what are the possible orders it can have? Matrix amagi 15 elements lairabadi matrix tugo itokpa yaba orders sindo kaya kaya. The possible orders are 1 into 15, 1 by 15, 3 by 5, 5 by 3, and 15 by 1. For question number 9, for what value of k is the function f defined by f of x is sin x by x, x does not equal to 0, and whose value is k when x equal to 0 is continuous at x equal to 0. Karamba k ki value na x have c f have a function c 0 the continuous oigedege. We are given that f is continuous at 0, so f of 0 equal to limit of f of x, x tends to 0 must be equal. But f of 0 is already given as k, and whose limit is 1. Therefore, the required value of k is 1. For question number 10, find dy by dx if twice x plus thrice y equal to sine y. Here twice x plus thrice y equal to sine y. Differentiating both sides with respect to x. For this we have 2 into 1, 3. 3 into y with respect to dy by dx, and cos y with respect to x is cos y into dy by dx. Transfer dy by dx and solve. We have dy by dx equal to 2 by cos y minus 3. For question number 11, what is the value of integral of e to the power x times 1 by x minus 1 by x squared dx? 1 mark. This is equal to 1 by x times e to the power x plus c. We have, remember, integral of this is ex into f of x. Here f of x is 1 by x and f dash x is minus 1 by x squared. For question number 12, find the integrating factor of the differential equation x times of dy by dx minus y equal to twice x squared. Pyramid bar linear differential equations integrating factor puto habani. Standard form thamani x na divide torne tam kuding makta. We have this. Then here which is equal to what? This form is equal to dy by dx plus p of y equal to q. Here p is minus 1 by s, coefficient of y. There, so integrating factor is e to the power. You have to integrating factor. Remember this. Integrand of p dx. Here p is minus 1 by x. The integrand of 1 by x is log x, which is equal to 1 by x. Therefore, integrating factor is 1 by x. 13. Find the angle between the vectors a and b with magnitudes √3 and √2 respectively. Having a dot b is magnitude of root over of 6. Here magnitude of a is √3, magnitude of b is 2. A dot b is also given as root over 6 theta. We have to use a dot b is equal to magnitude of a into magnitude of b into cos theta. Giving their respective values, we have cos theta is 1 by √2, which is equal to pi by 4. Theta equal to pi by 4. Question number 40. If a line has direction ratios 2, 1, minus 2, determine its direction cosine. Lai amagi direction ratios piram labadi cosine karam na cosine sindu putu. Here this is RL equal to a by root over a by root a square plus b square plus c square, that is 3. 2 by 3. For m we have 1 by 3. 1 by 3 also n equal to minus 2 by 3. We start the required direction rate cosines of the line. Question number 15. So that 3 times of the sine inverse x equal to sine inverse of thrice x minus 4x cube. X belongs to this interval. Mark 2. Let sine x is equal to y. Implies x equal to sine y. Now, sine inverse x is y. Putting that we have thrice x ni thrice y adu sine sum thanga the sine of thrice y, whose expansion in sine y is this. Sine y is already found to be x, which is equal to thrice x, which is also equal to 4x cube. Next, transfer sine on the right side. We have thrice y equal to sine inverse of this expression, but y is originally equal to sine inverse of x. This must be cancelled. Question number 16. Prove that the inverse of a square matrix, if it exists, is unique. Square matrix samagi inverse lerabadi ama kakto oigani praman tuma. Suppose B and C are two distinct inverses of a square matrix A. B amasung C A haribi square matrix asigi manadaba inverse ani ne haina loksel C. Then product AB equal to BA equal to I and product AC equal to CA equal to I by the inverse by the definition of the inverse of a square matrix. Now B can be written as B into I, law of identity matrix, which I is already equal to AC or CA, but I take I is equal to AC. Then next I have to use Matrix multiplication is associative property. Associative property, we have BA combined, and BA or BA product BA is already equal to I. Then I into C is what? I into C is C. Now B and C are equal, but we suppose B and C are two distinct inverses of A. Thus, our supposition is wrong. That is, B and C are different. Hence, the inverse of a matrix is unique if it exists. Matrix amagi inverse lerabadi amakakta oigani. Hence, proof. Question 17. Find the equation of the tangent to the curve y equal to this. Curve asida magi inverse putu u haibani. Here y equal to this. Find dy by dx. Differentiating both sides with respect to x, we have this. Put their respective value at 0, 5. We have x 0 in the laboratory phangani. Thus, the equation of the tangent at 0, 5 is y minus y1. Here y1 is 5 and equal to slope of the tangent is minus 10 times of x minus x1 is 0. Simplify, we have 10x plus y minus 5 equal to 0. So I can find the integral of this. Pirami by integrals about value about put to o haven. E to the power x, e to the power minus x, no matter to supuri, Roma card supuri, we have this. Now, denominator, numerator is derived e to the power x derivative to e to the power x, e to the power minus x derivative minus times of e to the power minus x. So, matak derivative or a. We have to use this formula. F just x divided by its function, that is this function, whose integral is equal to log of modulus of denominator. I have used this. Question number 19. Find the general solution of the first order linear differential equation dy by dx plus py equal to q. Find the general solution of the first order linear differential equation dy by dx plus py equal to q. The steps are: put in the form of dy by dx plus py equal to q, where p and q are constants or functions of x solely. Piramiba differential equation si ahanba step my standard form the thamani. Next, find integrating factor e to the power integral p dx masi value puthoni. Next, step third both side integrating factor multiply turning aduga put in the standard form of that the general solution is given by y into integrating factor equal to integrand of q into integrating factor plus c. Question number 20. If a vector equal to a1 I cap plus a2 j cap plus a3 k cap and b vector equal to b1 I cap plus b2 j cap plus b3 k cap, then show that a vector dot b vector is equal to a1 b1 plus a2 b2 plus a3 b3. 2 marks. We have a dot b is a value pixel or b value pixel or scalar product pangtoxi. Then a1 of I cap sina maningi vector should distributive property rule pangtoxi. Mathanda anisi dot pangto over the a1 b1 times of I dot I cap dot ik plus a1 b2 times of I dot jk plus a1 b3 times of I dot kk. Asumna a2 na puribagi a3 na puribagi su pangthoasi. Hujik I dot I habedi 1 ni I dot j perpendicular ba ani gi dot ti 0 ni habedu ningsing asi sigin silarani I dot id 1 ni j dot j su 1 ni duga k dot k su 1 atai singti perpendicular oiba ani gi dot ti 0 ni. Thus, hence proof. Question 21. The Cartesian equation of a line is this, right? Is vector form. Cartesian equation of a line is cinema ki vector form puthwabani. The vector form of the line of this line is r vector dot then line na jano false of point number ki position vector the 5 times of I cap minus 4 times of j cap plus 6 times of k cap plus lambda times of 3 I cap plus 7 j cap plus twice k cap. Question number 22. Find the mean of the numbers obtained on a draw of an unbiased die. Unbiased die ama hunbada phangban number singi mean putu 2 marks. Let x be the number obtained when a die is drawn. Die ama hunba matamda phangban number singu x na khangarasi. Then x is a random variable and which can take values 1, 2, 3, 4, 5 and 6. Also, probability of obtaining a number is 1 by 6. So min is e of x is equal to x1 x1 p1 plus x2 p2 plus x6 in p6. That is 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6. 1 by 6 the sum of the first 6 natural numbers this is 3.5. Question number 23. A person buys a lottery ticket in 50 lotteries, in each of which his chance of winning a prize is 1 by 100. What is the probability that he will win a prize at least once? But lottery ticket nipa amana. A person buys a lottery ticket in 50 lotteries. 50 lotteries ki ticket amaka inipa amana. Mahak na mai pakpagi chance si 1 by 100 ni. Yamdrabada mahak na mai amadagi tadana mai pakani haibagi probability kayano. Here n is 50 and p the probability of success is 1 by 100. So q is equal to 99 by 100. P of x greater than equal to 1 is 1 minus p of x equal to 0. Then 50 C naught 1 dagi mighty bagi probability se khaido khigani 50 C naught into 1 by 100 to the power 0 into 99 by 100 to the power 50 minus 0. Then whose value is this? We have this. Binomial binomial distribution in mafam asida palibasi. Question number 24. So that the function f from this closed interval to R defined by f of x equal to x divided by x plus 2 is 1 1. Function C 1 1 ulu ahanbada. Find the inverse of the function f from this closed interval to the range of f 4 marks. For this 1 1 ahanbada 1 1 utkani. Let x and y belong to the closed interval such that f of x equal to f of y, but f of x whose value is x divided by x plus 2. For f of y divided by y plus 2. Cross multiply and transfer cancelling, we get x equal to y. Unique solution. Therefore, f is 1 1. First part is over. For range of f PD, we have x plus 2 is greater than x. We have x plus 2 is greater than x for all x belongs to the closed interval. That is f divided by x plus 2 is less than 1, which is equal to f of x. F of x is always less than 1. Therefore, range of f is open interval minus infinity 1. On to let y equal to f of x, which is equal to x by x plus 2, and cross multiply y with this, we have left side, and for right we have x, from which we have to solve x, which is equal to twice y by 1 minus y, belongs to the closed interval when y does not equal to 1. Y no 1 it implies f is onto function, hence f is invertible. To find f inverse, mathakta phangoriba x asi f inverse of y na sindokro right at the length na thamasi, then which is the inverse of the given function. Then y is replaced by x, which is the inverse of the function. Question number 24. Or let asterisk be the binary operation on n given by asterisk b is LCM of a and b. Is asterisk commutative? Is asterisk associative? Find the identity of asterisk in n, the set of natural numbers. Which elements of n are invertible for operation asterisk? ꯑꯍꯥꯟꯕꯗ ꯄꯤꯔꯝꯃꯤꯕ binary operation ꯑꯁꯤ commutative ꯑꯣꯏꯕ꯭ꯔꯥ ꯌꯦꯡꯁꯤ. Here asterisk b is LCM of a and b. We have asterisk b is LCM of a and b, which is again equal to LCM of b and a, and which is equal to b asterisk a. Thus asterisk b equal to b asterisk a. Yes, asterisk is commutative. For associative, we have asterisk b of asterisk c is equal to LCM of a and b asterisk c, which is again equal to LCM of a, b and c, which can be all, and the asterisk of b asterisk c is equal to asterisk of LCM of b and c, which is equal to LCM of a, b and c. Therefore asterisk b of asterisk c equal to asterisk of b asterisk c for all a, b, c belongs to n. Yes, asterisk is associative. For identity, let E be the identity element in n, then E asterisk a equal to asterisk E equal to a. Implies LCM of E and A equal to, which is LCM of A and E equal to A. Therefore, LCM of A and E is A. Implies E equal to 1, which is true only when E is 1 with natural number. So, E equal to 1 is the identity element. Let A belongs to N be the invertible elements of for asterisk. Then there exists element B belongs to n such that asterisk B equal to B asterisk A equal to 1. Else implies LCM of A and B equal to LCM of B and A equal to 1, which gives A B equal to 1. A so B is mukul khudimok 1 oigani. Thus 1 is only invertible element for asterisk in n. Binary operation asterisk n defined over binary operation asterisk की invertible element से 1 खत्म. Question number 25. Express the matrix A as the sum of asymmetric and skew-symmetric matrix for marks. We have learned that A can be expressed as half of A plus A transpose plus half of A minus A transpose. Now A plus A transpose, A is this whose transpose is first column, first row, first column, second row, third column, third row, and sum up we have this. Implies half of this matrix is half 2 nalone divided we have this, which is symmetric matrix. Again A minus A transpose is this whose transpose is this, and subtract we have this. Half number both sides of this, right at the 2 divided we have this, which is symmetric. Diagonal element purna mark 0 or non-diagonal the label corresponding the label single C aman additive inverse or skew symmetric. Thus given matrix is sum of asymmetric matrix and skew symmetric matrix, hence proof. Question number 26. Find dy by dx if x to the power y plus y to the power x equal to 1. 4 marks. Here x to the power y plus y to the power x equal to 1. X to the power y with u the thambara y to the power x for b and thamba we have this. Differentiating both sides with respect to x we have this. Since u equal to x to the power y, taking log on both sides and differentiating both sides with respect to x and solve, we have to solve du by dx. Du by dx is equal to this. Again b equal to y to the power x, taking log on both sides and differentiating both sides with respect to s, we have this, from which we have to solve dv by dx. dv by dx is this. du by dx found out, dv by dx is also found out, putting the value of du by dx and dv by dx in above 1. We have this, from which we have to solve dy by dx. dy by dx solved to we have this. Hence dy by dx is found out. Question number 26. Prove that the greatest integer function f given by f of x equal to x within third bracket x lying between 0 to 3 is not differentiable at x equal to 1 and at x equal to 2. 4 marks. Pyramid function is the greatest integer function derivable at x equal to 1. 11 derivative at 1 is denoted by this, whose value is 1 plus x, 1 plus h. H is a negative number, therefore 1 plus h is less than 1. That whose value is 0 and whose 1 is integer, whose value is 1. Minus 1 by h. H is a negative, small negative number, therefore minus 1 divided by a negative number is again a positive with greatest value, that is infinity. Thus, left-hand derivative does not exist at 1. Hence, f of x is not derivable at x equal to 1. Similarly, derivable at x equal to 2. Similarly, left-hand derivative at 2 denoted by this. F of 2 plus h, whose value is 2 plus h. H is a small negative number, therefore 2 plus h is a number just less than 2. That is, whose value is 1, and 2 is integer, whose value is 2. That is minus 1 divided by a small negative number, which is also infinity. That is, negative divided by negative is plus. Then if s denominator is numerical value to p makhaydi infinity laani divide to 1 divide already. Thus, 11 derivative does not exist. Hence, f of x is not derivable at x equal to 2. Question number 26. Verify Rolle's theorem for the function this. In closed interval minus 4 2. F of x is this. Number 1. F of x is continuous in the closed interval minus 4 2 as it is a polynomial function. F dash of x is twice x plus 2 exists in this open interval, and hence f of x is derivable in open interval minus 4 2. And f of minus 4, whose value is obtained when x is replaced by minus 4, we have 0. And f of 2, which is also 0. Rights are equal, therefore lefts are equal. That is, f of minus 4 equal to f of 2. Thus, all the conditions of Rolle's theorem are satisfied. Then there exists at least one point C belongs to the open interval minus 4 2 such that f dash of C equal to 0. Implies f dash of x is this. Therefore, x replace x by c. We have twice c plus 2. Solve c equal to minus 1, which belongs to this open interval. Hence, Rolle's theorem is verified. Question number 20. I prove that integrand of f of x dx between minus a to a is equal to 2 times of integral of f of x dx between 0 to a if f is an even function, and whose value is 0 if f of f is an odd function. 4 marks. We have this interval is sum of two intervals. This definite integral is expressed sum of two definite integrals, which is here, and sige function similarly. Sige function similarly, the first one the irasi sige function similarly the second the let x equal to minus t in the second integral. X to minus t hand thamasi in the right hand side ki x to has is second integral the thamasi. Then dx to the kaya pange minus dt ka manarani. When x equal to minus a, x equal to minus a, x to minus a or t value do t value x na minus a or x to minus a or kaya pange t value a. And when x is 0, x is 0 or t value 0. Therefore, given the definite integral becomes this. Simple first integral nilengana thamo, second to receive hangani, but limit ani si interchange sororobadi minus sama lakani. Madugi minus ka sige minus ka thengaina di plus lairani. Then a cinema kakrani 0 cinema kakumani hanegi t singadu singadu x on top of this is equation 1. If f is an even function, then f of minus x equal to f of x. Even function haibadi f of minus x na f of x ka manababuni matam punnamakta. And f is an odd function, then f of minus x is equal to minus of f of x. Mataki function is equation 1 is jealousy given definite integral equal to then even oiragana f of minus x to f of x na sindokrani odd oiragana if f is an even function odd function or the f of minus x to minus f of x na sindokrasi this become this orani then manabani tisnaradi twice lairani manabani khaidoknar same magnitude but opposing sign or the zero phangani hence proof. Question 29. Using integration, find the area of the triangular region whose sides have the equations y equal to twice x plus 1, y equal to thrice x plus 1, and x equal to 4. 4 marks. Solution. Then see standard form the thamnanabagidama symmetric form of straight line have the x by a plus y by b equal to 1. Intercept form of straight line that thangani graph equal line and nabagidamaka. Asumna 1 sibu sumana thamba yai cd 1 c minus 3 sumana thamba yai then cd lengana thamasi. The points of intersection for points of intersection for first two lines line anisigi point of intersection gi damakta di line ani or this sig line anisigi point of intersection gi damakta di we have left ani manarabadi right ani manarani there is twice x plus thrice x plus 1 x to solve to 0 x to 0 pixel of the y value automatically 1 or a therefore mabani ke kana from a and a whose coordinates are 0 1 this is 0 1 this is 0 1 the first line in x equal first line ga x equal to 4 ga first line ga x equal to 4 ga mabani ke kana from the damak x value 4 pixel x value the 4 pixel of the y value the 9 or y and 9 or the x 4 or kabane then b correct 4 9 b ki coordinate c correct 4 9 si ohele 4 9 sunna the second line in x equal to 4 a second line siga x equal to 4 ga ani sigi point of intersection ki damakta di x the 4 pixel we have y equal to 13 therefore c mark ki bar text mark coordinate 4 13 orani bar text ahun sigi khange sigi triangle sigi area consider it sigi area pu thokadare the required area the area of triangle abc ne which is equal to what masi kaya ga manai haragade masi kaya ga manai haragade mataki triangle sina mataki line sina triangle the same iba area si x axis area sidagi sigi line sina x axis to same iba area se khaidokrabadi area between them that is mataki line sigi y ki value the thrice x plus 1 makhagi line sigi y ki value the twice x plus 1 then x ranges from 0 to 4 0 to 4 simplify toro integral toro fundamental palo evaluate toro I square units pangan 30. In a bank, principal increases continuously at the rate of 5% per year. Bank amada principal di sahi puding 5% hengatli. An amount of rupees 1000 is deposited with this bank. Mahariba bank asal policing amagi amount deposit toksele. How much will it worth after 10 years? 10 years tamaki amount kaya oigadage hangmani. Solution, let P be the principal. Then dp by dt. Principal hengatpagi sangdo 5% of the principal ne 5% of the principal ni silare. Separation of variables palani aduga integrate torani. We have CD log p lerani sigidi t lerani 1 by 20 times of t plus log c log sele. Log ani sig mai gaya muda punche log. Then log mangal c p by c equal to e to the power t by 20. Then p equal to c is times of e to the power t by 20 lere. When t is 0, initially time value is 0 ni matamad p value is 1000 or ani mataki equations we have this from which we have to solve c is 1000. Thus above becomes p equal to 1000 times of e to the power t by 20. When t is 10 years with 10 pixels we have t the 10 pixels the 10 by 20 the half is 0.5 ni e value is 0.5 pyramid other high number pixel purinero we have rupees 1648 After 10 years, the mahaki amount to 1,648 oigan. Sahid of 5% is ang hengatpanina. Question number 31. So that the points A, whose position vector is this, B, whose position vector is this, and C, whose position vector is are collinear. Point on to collinear ullu hyphen. We have AB vector, position of vector B minus position vector of A. Subtract, we have this. And BC, position vector of C minus position vector of B. We have this. Then we have AB is equal to 2 times of BC. Shidagi 2 times of BC. Here AB is equal to what? BC is equal to the BC. This must be BC. BC vector is equal to 2 times of AB vector. This is wrong. This shows that AB and BC are collinear and B is common to both. AB ga BC vector ga collinear vector sini B na common over point ore. Thus the points A, B and C are collinear. Point on the collinear we have to command out. Question number 32. If a vector equal to this and find A inverse, using A inverse, solve the system of equation this 6 marks. For this, we have to find out determinant of A is equal to -1, which does not put 0, therefore A inverse exists. For cofactor A11, we have this. For A of 1, 2, whose cofactor is 2, A of 1, 3, whose cofactor is 1, A of 2, 1, whose cofactor is -1, A of 2, 2, whose cofactor is -9, A of 2, 3, whose cofactor is -5, A of 3, 1, whose cofactor is 2, A of 3, 2, whose cofactor is 23, A of 3, 3, whose cofactor is 13. Therefore, adjoint A is transpose of the matrix formed by the cofactor. This is first row whose transpose is first column. This is the second row and whose transpose is this. This is third row whose transpose is this. And A inverse is 1 by determining A into adjoint A. Determinant is already found to be -1 into adjoint A is this. Then -1 multiplied already we have this. But the given system of equations can be written in matrix form as this. But in Mahaki inverse, no both sides multiplied already we have this. Mahaki inverse to the C uhere. Maduri si mamang sila kuna thamani the column matrix form by constancy. Anisi Mahaki inverse to the C or thamani si thamaba matungda siga multiply taro si thangani. Then x ka 1 ga manare, y ga 2 ga manare, z ka 3 ga manare. Thus x equal to 1, y equal to 2, z equal to 3. Question number 33. So that the semi-vertical angle of the cone of the maximum volume of given slant height is tan inverse of √2, 6 marks. Maximum volume piba cone amagi semi-vertical angle do tan inverse of √2 oigani given slant height over matamda. Let VL theta be the volume given slant height and semi-vertical angle of the cone. Then volume is 1 by 3 pi r square, as here r is CD and the ice is AC. But CD is equal to, applying trigonometry, we have L times of sine theta, and AC altitude is equal to L times of cos theta. Giving their respective values and simplify, we have this. dV by d theta is this. Rudder rule policy, we have this. Then simplify it over the equation. Whose derivative respect to theta is the theta namuk derivative log of the simplest form of thamani. Now dV by d theta equal to 0. See 0 ga man halabadi, we have this. Degi muk sin theta factorize toro, either sin theta equal to 0, sin square theta equal to 2 by 3. There is theta equal to 0 degree or sin theta equal to plus minus root over 2 by 3. Therefore, sin theta is root over 2 by 3. Theta equal to 0, the cone himong which is impossible minus 2 oitopong machina by the way the 180 degrees hour negative angle of the 3 When sin theta is root over 2 by 3, then d square b by d theta square, whose value is this, which is always less than 0. Thus, the volume is maximum when sin theta is root over of 2 by 3 and cos theta is 1 by root over 3. That is tan theta is sin by cos. Dividing this by this, we have root 2. Implies tan theta is of tan inverse of root 2. Hence proof. 33. O. A window is in the form of a rectangle surmounted by a semicircular opening. The total perimeter of the window is 10 meters. Find the dimensions of the window to admit maximum light through the whole opening. Window amakak rectangular form the lay semicircular opening ama yauraga. Total perimeter adu 10 meter ni maximum light changnanabagi damakta dimension window ki dimension to put to let A B C D be a rectangle and a semicircle is drawn with CD as diameter. CD na diameter or semicircle na may let ABC X meter log C and BCC Y meter log C. The perimeter of the window to the X plus 2 times Y plus semicircle circumference ki tangkai di twice pi r. Here X is diameter, X na diameter di my radius di F by 2 or ni twice pi r ni twice pi r is circumference di magi semicircle di twice pi r da 2 ni yellow di pi r di mapamasi X by 2 or ni we have which is given as 10. From which we have to solve y. Equation is the y solved and we have this y equal to 20 minus twice x minus pi x by 4. Let X be the area of the window. Then area adu the rectangle ki area di length into breadth xy plus semicircle ki area adu the circle ki area pi r squared to the yellow semicircle or the pi r square r di kano x by 2 x na diameter or na radius to the x by 2 or name half of pi r square. That is we have this. Now ax a function of x ta thang model what ki y ki value is singular y ki value is singular value we have this the x na puri ro we have this. Then see simplest form the derivative law see x the derivative law see phangani amoksu double derivative second order derivative to see which is constant with a negative prefix. For maxima or minima, we have to put a dash x equal to 0 and which is equal to 0, solve x equal to 20 by pi plus 4. When x is 20 by pi plus 4, a double dash of x is less than 0. Therefore, x is maximum when x is this and y is y value this is x value which is like a solved when we have 10 by pi plus 4 meter. Thus, the dimensions of the rectangle are 20 by pi plus 4 meter by 10 by pi plus 4 meter. Find the integral of this x minus 1 whole square into x plus 3. Let I equal to this. Let we have to put integral this must be x square plus 1. Then a by x plus 3 plus b by x minus 1 plus c by x minus 1 whole square. Denominator of x minus 1 whole square into x plus 3 on both sides of it we have this. Put x equal to 1 we have 2 equal to 4c with c equal to half. Put x equal to minus 3 we have 10 equal to 9a which gives a equal to 10 by 9. Equating coefficient of x square on both sides we have for right side we have a plus b, for left side coefficient is 1. Solving b equal to 1 minus a, but a is equal to be found to be 10 by 9. Then 1 minus 10 by 9 is minus 1 by 9. Therefore I becomes I singular I gives c multitude singular common log thokra the 1 by of x plus 3 integral the log of this and the sig is the mana later minus 1 by log thokra log of modulus of x minus 1 sig is power palabadi icon sip hangane then their respective values will simplify to see integral to 0. Question number 34 or prove that this integrand of log of sin x dx between 0 to pi by 2 is equal to minus pi by 2 log 2 sigma. Let I equal to this. Also I equal to this. X2 pi by 2 minus x plus correct. Then sine of 90 minus x the cos of x which is equation 2. And is adding to we have I plus I twice sine. And is adding to we have this. Among pi by 2 among common lotocracy integral and is assume pange and is property parliament si pangani. Then see twice panjangarabadi 2 matata puri singram by 2 later. Then log of this by this, the log of this minus log of 2. But see the amukayagamana, see the I1, see the log 2 log 2 probably when the x integral the x learning x is power pi by 2 learning. Then which is I1. Question 3. Continued. I1 is equal to this. Then which is equal to twice x asi theta the putting toro the x to the half the theta lerani when x equal to 0 x the 0 pisila with the theta value 0 when x is pi by 2 x the pi by 2 pisila with the theta value pi phange. Therefore this tends to 0 to pi log of sin theta the x value the half the theta ni 0 to pi le half log thokro amuksu. Then sigi pi have a sekaram ibi haragati pi have a say I 2 times of pi by 2 haina ibi. Then 2 do mama song harani karigidamak song haribano haragati log of sine of pi minus theta say she amuk log of sine theta the return tarokoli. Then half ko 2 ka kakthana we have this. Masidi pi by 2 lare cd x theta khudumak x on top pro which is equal to I. Masimata ki equation de sinjalabadi 3 de sinjalabadi left twice I lehui I wanga jagada I thamani right minus pi by 2 log 2 lan I na left thangabadi I equal to minus pi by 2 log 2. That is originally this equal to minus pi by 2 times of log 2. Hence proof. Question number 35. Find a vector equation of a line passing through 2 points in the form r vector equal to a vector plus lambda times of b minus a vector. Also derive the Cartesian form x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1 6 marks. Let A and B be the position vectors of 2 points A and B on the line, as in this picture. Line is still a point and the position vector on the log solus. Let R be the position vector of any point P whose coordinates are taken as x, y, z. P has any point in mass position vector R log solus. Then P is a point on the line if and only if AP vector equal to R minus A vector and AB vector equal to B minus A vector are collinear vector. A degi P vector siga. A degi B vector siga. Anido point ahum si collinear. Ani si collinear vectors or P have a line as the Therefore, P is on the line if and only if R minus A vector equal to lambda times of B minus A vector. Mafam asida lambda is karina lambda with any real number. That is, this equal to this R vector solved or we have this equation 1. This is the vector equation of the line passing through 2 points whose position vectors are A vector and B vector. For Cartesian form, we have R vector A vector की coordination ratio बदी R vector C P vector की coordinates x y x y z ओरबदी मां की position vector r दुरी x times of I k plus y times of j k plus z times of k k ओरनी. Then A vector D A hari babate x1 y1 z1 ari मां की position vector c का मानने B स्वसुम c का मानने hari value ahum asi mathak equation 1 is jealousy. Substituting these values in equation 1 we have then similarly, equating the both sides, equating the coefficient of I cap, j cap, k cap, we get this. X for I cap is pangani, j cap is pangani, k cap की coefficient is pangani. Sri lambda solve to si, lambda solve to ro, sri lambda solve to ro, lambda solve to ro, makoi ahum mana ragadi, makoi ka mana ba expression ahum no mana rani. We obtain this. Which is the equation of the line in Cartesian form? To talk about Cartesian form is in hence proof. 35 or find a vector equation of a plane perpendicular to a given vector and passing through a given point in the form r vector minus a vector dot n vector equal to 0. Also derive the Cartesian form a times of x minus x1 plus b times of y minus y1 plus c times of z minus z1 equal to 0 from the vector form 6 mark. Let apiba vector aduna chini aduga apiba point ama phawa given vector perpendicular to a given plane. So kada with let q be the given point whose position vector be a vector and p be any point on the required plane whose position vector be r. Let n be the given vector perpendicular to the plane. Plane adu blue na toriba parallelogram asina plane asingasi plane adu the perpendicular over vector ni n hariba vector si. Then q dagi pida saliva vector q dagi pida saliva vector asi kaya orane r vector minus a vector. Also p vector is perpendicular to this vector. Therefore their dot must be 0. Putting their respective values we have this. This is the vector, this is the equation of the plane in vector form. For Cartesian, let Q be x1, y1, z1, P whose coordinates are taken as x, y, z. Direction ratios of the Norman to the plane are A, capital B, capital C. Let then a vector equal to this, R vector equal to this, N vector equal to this. Putting these values in the above equation, using this we get putting their respective value and according to probability we have this. This is the vector, this is the equation of the plane in Cartesian form. Question number 36. There are two types of fertilizers F1 and F2. F1 consists of 10% nitrogen and 6% phosphoric acid, and F2 consists of 5% nitrogen and 10% phosphoric acid. After testing the soil conditions, a farmer finds that she needs at least 14 kg of nitrogen and 14 kg of phosphoric acid for her crop. If F1 costs rupees 6 per kg and F2 costs rupees 5 per kg, determine how much of each type of fertilizer should be used so that nutrient requirements are met at a minimum cost. What is the minimum cost? Let X and Y be the number of kgs of fertilizer F1 and F2 respectively. Let P be the minimum cost. Then the problem is to minimize Z equal to 6X plus 5Y subject to the constants 10% of nitrogen in then X kg study, 10% of X1 in then mathangidi 5% of Y or already similar which must be greater than 14. I have this simplified that we have this. For phosphoric acid ki damak to samu compared 6% of 6% yeah we have an S kg to similarly then phosphoric mathangidi 10% of I have an the 10% of y is which must be greater than equal to 4. To simplify it, we have this. Then xy greater than equal to 0. By drawing the inequalities, we get the feasible region PCB with this. I call a feasible region as the PCB as a this is part, this is C, this is P, this is P. With what it says, P की C की vertex is 700 by 3 equal to 0. P की vertex equation ani si solve tawraga phangani. Equation ani se solve tawraga phangani. Makoi ki point of intersection ki damakta solve to P की coordinate si phange B की coordinate ti hana ye ko yaw kare B की di 0 to IT lerane. H.C. the value of Z. H.C. the value of Z kaya hoigani. H.C. the value of Z 6 into 5. 6 into 5 there. At B the value of Z is this. At B the value of Z is this. Value anising manungda mayasung the 5 people 100 ni 1000 ni. The feasible region is unbounded. Feasible region is unbounded. Unbounded or the tonganba criteria kharaga amuk unbounded or feasible regions. Unbounded. Check by drawing graphs of this. Apikpa numbers tiki pikpa. Max 6x plus 5y less than 1000 C graph ye kani. Mark half plane namalagani dotted amount syllabus mark half plane. Thus the resulting feasible region hana phangiba line asang singba feasible region siga with half plane dotted na represent over siga has no common point. Makoi common point amata laitre. Hence, the minimum cost is rupees 1000. 1000 segi hena pipa. Hana phangiba 1000 sina minimum value oibiyai oidabiyai. Repeat oirena khala common point later banina. When matamadu x 100 and IT are the number of kgs of fertilizers F1 and F2. Haribo ulmatamu chamme. 37. A manufacturer has three machine operators A, B, and C. The first operator A produces 1% defective items, whereas the other two operators B and C produce 5% and 7% defective items respectively. A is on the job for 50% of the time, B is on the job for 30% of the time, and C is on the job for 20% of the time. A defective item is produced. What is the probability that it was produced by A, it was produced by B? 6 marks. Let E1 and E1, E2, E3 be the events of the time consumed by machine operators A, B, and C for job. Then P of E1 is 50%, P of E2 is 30%, P of E3 is 20%. Let A be the event of producing defective item. Then P of A by E1 is 1%, P of A by E2 is 5%, P of A by E3 is 7%. By Bayes theorem, the required probability for the first one produced by A, we have P of E1 by A, which is equal to this by Bayes theorem. Then putting their respective values, simplify, we get 5 by 34. For second case, P of E2 by A, which is equal to this by Bayes theorem, and putting their respective values, simplify, we get 15 by 34. Thanks for watching.